summary of permutation. Definition. Permutation is an ordered arrangement of distinct objects. The number of permutations of n distinct objects is n factorial. This is when all n objects are being ordered. The number of permutations of n distinct objects taking r at a time is npr. Now only some of the objects are being ordered. The formula is npr equals n factorial over n minus r factorial. This formula is on your formula sheet. Example 4. These questions are getting tricky, but once you have the idea, they are kind of fun. Write each expression without using the factorial symbol. np2. We use the formula, so we have n factorial on the top and n minus 2 factorial on the bottom. This is where it gets tricky, as we don't know what n is, and we want to get rid of the factorial signs. First step. We ask which is smaller, the top or the bottom. If you're unsure, just randomly plug in a number for the unknown. Let's say 5. The top would then be 5. The bottom, 5 minus 2, or 3. So the bottom is smaller. Rewrite the bottom as it is. Now the top. From the general equation for factorials, we know that n factorial is n times n minus 1 times n minus 2 times n minus 3, and so on down to 1. We start writing this out until we match the bottom part of the fraction. So, n times n minus 1 times n minus 2, stop. This is what we have on the bottom. We'll add the exclamation mark to remind us that we could continue down to 1 if we wanted to, but in this case we don't. Now, the n minus 2 factorials cancel each other out, and we are left with n times n minus 1. No factorial sign remains. For b, similarly, we start by deciding whether the top or the bottom is smaller. The bottom, in this case. If we were to make n equals 5, then the top would be 7, and the bottom would be 4. So we rewrite the smaller one, n minus 1 factorial, on the bottom. Now, we want to start breaking down the larger part. So we start counting down. We start with n plus 2 times, we need to take 1 away. So now it's going to be n plus 1 times, we take another 1 away, it's now going to be n, times, take 1 more away, n minus 1, oh, stop. It matches the bottom. Add the factorial sign to say we could go further, but we're not going to. Now, the n minus 1 factorials cancel out, and we are left with n plus 2, n plus 1 times n. Example 5a, solve for x. This is very similar to what we just finished doing, but because we are asked to solve for x, and we have an equal sign, we are actually going to find the number that x represents. We start out the same by writing out the formula. X factorial over x minus 2 factorial, and then we'll break down the higher factorial and leave the smaller one, the x minus 2, on the bottom. We'll set this whole thing to equal 42. We cancel out the x minus 2 factorials, and what are we left with? X times x minus 1 equals 42. At this point, we should be able to solve by inspection. Go ahead if you can. X and x minus 1 are consecutive numbers. That means that they fall next to each other on a number line. Can you think of two consecutive numbers that multiply to 42? What about 7 times 6? If x was 7, then x minus 1 would be 6. 7 times 6 is 42. You have actually just solved x equals 7. You're done. If you're uncomfortable with that, you can still solve this algebraically. So let's move on. Using the distributive property, we would multiply the x through the bracket. So we would get x squared minus x equals 42. If we subtract the 42 from each side, we get x squared minus x minus 42 equals 0. Recall from Math 11, in order to solve, you now need to factor. So we need to find two numbers that multiply to negative 42 and add to negative 1. This would be negative 7 and positive 6. So we now have x minus 7 times x minus 6 equals 0. If x was 7, the first factor would then be 7 minus 7, or 0. So indeed, that would all equal 0. And we're done. Now, you might also wonder why x wouldn't also equal negative 6. Well, it does. But because n and r must be natural numbers, we will reject x as negative 6 because of the negative. 5b. Again, we are solving for x. And we have 6px equals 120. We fill in the formula as we did before. We would have 6 factorial on the top, 6 minus x factorial on the bottom, and it equals 120. In this case, the variable that we are trying to solve is in the bottom of the fraction. And we can think of the 120 as being 120 over 1, and we can actually cross multiply here. So if we do 6 factorial times 1, we just have 6 factorial equals, cross multiply the other two, is 120 times 6 minus x factorial. And then we divide each side by 120, and we actually compute what 6 factorial is. We can throw that into our calculator to get 720, and we are left with 720 over 120 equals 6 minus x factorial. We do the division, and we get 6. So 6 now equals 6 minus x factorial. Now the real trick here is to get a factorial sign on both sides of the equal. And we do start recognizing these after a while, but you could always just start plugging in numbers in the calculator if you're unsure. But 6 is the same as 3 factorial. So I'm going to rewrite 6 as 3 factorial. We still have 6 minus x factorial on the other side. But because we have a factorial on each side of the equation, we can now cancel those out. So the 3 has to equal 6 minus x. And then doing the algebra, we would find that our answer would be x equals 3.